Another day, another Maker Advent, and today we go back to building electronics. It's also the obligatory CircuitPython episode. CircuitPython's a version of MicroPython, which is Python for microcontrollers. Really Python 3 for microcontrollers. CircuitPython is from Adafruit, and it makes it simpler to use Python on a microcontroller by having lots of fantastic libraries and resources that you can just use straight away. So I'm using CircuitPython because I want to do MP3 playback, so audio file playback, and CircuitPython has it built in. To be fair, MicroPython does as well, but I'm more accustomed to using CircuitPython in this case. Anyway, I'm prattling on. What's the project? The project is that gold box there. Got this from a card shop the other day for £1, which was an absolute bargain, and I've done some electronic hackery inside. So let's show what it does first. I'm going to lift up the lid. Are you ready? There we go, the Maker Advent theme. So what we've got in there is a Raspberry Pi Pico, the original. No Wi-Fi, no nothing, just a standard £4 board, $4 board. It's going to play the music again. Let's unplug that. I've got an amplifier, an OEP 3-watt, OEP 3W. I got a load of them years ago. I used them for a chainsaw project, a toy chainsaw, giving it sound effects. It's a 3-watt amp. That uses 3 to 5 volts in power and just takes an output signal from the Pico, which is playing an MP3, which is being output as PWM on GPIO 18. Takes that as an input and spits it out as an output to the speaker, which looks very similar to the old laptop speakers from ages gone by. In fact, I've got some bigger ones of these kicking around somewhere. Anyway. And then just bodged into a case. Ideally, I'd shrink all this down or put it in a bigger box if it's a bigger present, but for the purpose of showing off a video, there we go. Right, let's go over to the computer and I'll show you the circuit and the code for this so you can build your own. One moment, please. Okay, so here is the circuit and the code for this project. I'm going to go through the circuit first of all. So you can see the Raspberry Pi Pico there, and there's multiple connections to it. I'm going to break it down nice and simple. At the top right, the first black wire goes from the ground of the Pico to the ground of the amplifier. Moving down from there, the red wire, which is 5 down, connects to the 3-volt output of the Pico and goes to VCC on amplifier. So that's giving the amplifier power to operate. Moving down, the next black wire is another ground, and that is on the input minus input ground of the amplifier. It's only a mono file that I'm playing, so I don't need to have stereo sound, so I'll just ground one of the pins. So I chose to ground the negative, the in minus. Going further down, that orange connection is GPIO 18. Looking at the code there to make sure I got it right. The orange wire goes to input plus. That's a PWM output, which is outputting the MP3 music to the amplifier, which then amplifies it and sends it out to the 2 speaker connections, red and black, SP plus, SP minus on the amplifier in the top right. So that's the amplifier circuit and output done. It's really easy, to be fair, just making sure it's got power and it's got the connections for the music to come out to it. That's it. Going down, the last black wire on the Pico, which is 3rd from the bottom, is just another ground pin. And that connects 1/2 of a reed switch, a magnetic switch, to the Pico. The other side, the yellow wire, goes to GPIO 15, and that pin in the code is pulled high, so it's on at 3.3 volts. So when the reed switch isn't activated, so there's no magnet near it, the circuit is broken and that pin remains high. When a magnet's introduced, the reed switch will close, and that will connect GPIO 15 to ground, which will pull the pin low. And that's our change of state that denotes some functionality in the code, which I'm going to come to now. The code for this is taken from Adafruit's excellent example on MP3 playback on a Pico. All I've done is add a little bit of code here and there just to do what I want. In their code, it's just simple. Open the file, play the file, stop. But I wanted to trigger the reed switch for this one. So let's go through line by line. We've got import board, enables us to use GPIO. Import digital I/O to use digital pins, so on, off functionality. We've got the audio MP3 library for playing back MP3s. And audio PWM I/O, so using PWM on output pins. We're setting up the switch there, So the object is called switch, and it's a digital I/O. So it's an input and output. It's on GPIO 15. The direction, is it an input, is it an output? Well, I said, okay, make it an input. Then I said, right, switch pull that pin high. So I pull it to 3 volts. I then create an audio object. So I can use PWM audio, not easy to say at 8:15 in the morning, and tell it that GPIO 18 is going to be our output pin. Then we've got a decoder object, which is really just decoding an MP3 file. It's going to open the file, Christmas load.mp3. If you look in the files over here, actually on the Pico is Christmas load.mp3. That's a 22 kilohertz audio file, so not the best quality in the world, but the speaker, to be fair, isn't the best quality. It doesn't need to be. While true, do this forever. If the switch value, so the read switch, is true, so the pin is high, so it's not connected to ground, play the audio file using the decoder object, and we have to put down while audio is playing, pass. If you don't do that, it just stops instantaneously. And the else condition is just a pass. It just keeps looping round and round and round. That's when the lid is closed, the magnets close the read switch, so that pin is pulled down. So that change of state says, okay, I just wait here until something happens. It's only when the lid is lifted that the magnet moves away from the read switch that it actually triggers the sound to play. And then at the end, I've just left that in. I should have took it out, to be fair. I'd have put print done playing. That was in the Adafruit example. So that is all the project code and the circuit. I'll put all of this on GitHub so you can download it and play around with it and have a bit of fun. And that's it for today. I'll see you tomorrow. Ta-da!